Dear students, now let us see this question. So, an ideal gas is taken from state A to state C via three different processes ABC, AC and ADC. So, we are supposed to move this gas from state A to state C and we are traveling in three different processes. First from A to B and B to C, this is one process, A to C second process, A to D and D to C is the third process. Clear? And it is given that internal energies of the gas corresponding to the states A and C are P0 V0 and phi P0 V0. So internal energy of state A is P0 V0 and internal energy of state C is phi P0 V0. Then we are supposed to find out these values. So what is the change in internal energy of the gas from A to C? Work done during the process D to C and A to B. Total heat energy supplied during the process ABC, AC and ADC. So let us see how we can do these questions. So first of all, let us try to do this question. So what is the change in internal energy of the gas from A to C? So in traveling from A to C, how much will be the change in internal energy? So already we have studied previously that internal energy is a point function, whereas heat supplied or work done, they are path functions. So path functions in the sense that they depend on the path which we have taken. But internal energy just depends upon the initial point and final point, and whatever may be the path taken, it doesn't depend on that. So therefore, internal energy at A is given as P0 V0 and internal energy at C is given as phi P0 V0. So change in internal energy can be written as delta U is equals to U of C minus U of A. This is how I can write. So internal energy at C is how much? Phi P0 V0 and internal energy at A is P0 into V0. So therefore, change in internal energy from A to C will be 4 P0 V0. And it is independent of whatever process we have taken. Whether we have moved from A to B and B to C or directly from A to C, or we have moved from A to D and D to C, it doesn't depend on that. So whatever it may be, the change in internal energy will be 4 into P0 V0. Okay, so this is the answer for the first question. Now let us see the second one. Work done during the process D to C and A to B. So where is D to C? This is D to C and A to B. In these two processes, we are supposed to find out work done. So already we have studied that. So the area under PV graph, it gives the work done. For example, if I want to calculate area under DC graph, so this area under DC graph, it will give the work done in the process from D to C. So therefore, DC, so work done can be calculated as, what is the area under this graph? 2 V0 minus V0 is V0. And breadth will be P0 minus 0, which will be P0. So therefore, work done from D to C will be P0 into V0. So this should be our answer. Similarly, what will be the work done from A to B? And in moving from A to B, again the total area under this AB graph, it should give the work done. So what is the area under AB graph? So work done should be, so let us call it as breadth here. So 2 V0 minus V0 is V0 into, now what is the total pressure which is under this graph? Total pressure is 2 P0. So therefore work done under A to B graph will be 2 P0 into V0. So this will be the amount of work done. So just area under P0 V0 pressure and volume graph, it should give the work done. This already we have discussed many times. So now let us see the third question. And what is the third question he is asking? Total heat energy supplied during the process ABC, AC and ADC. So first let us take heat supplied under the process ABC. Okay. So we know that delta Q is equals to delta U plus delta W. So this is according to the first law of thermodynamics. Clear? So total heat supplied should be equal to the change in internal energy, which we have already calculated, which is equal to 4 P naught V naught. Now we are supposed to find out delta W. What is the amount of work done? Now if I observe this process A to B and B to C. So from A to B, already we have calculated what is the work done. A to B is 2 P naught into V naught. Now what about work done from B to C? That is the question. So can you say what is the amount of work done in traveling from B to C? So here, in traveling from B to C, work will not be done because volume is a constant. If volume is a constant, it is an isochoric process. In an isochoric process, work will not be done by the gas or work will not be done on the gas. This already we have discussed. So work is done only from traveling from A to B itself. So therefore, how can I write? So delta Q is equal to delta U. What is the change in internal energy? 4 P naught V naught plus work done only from A to B. Work done from A to B is 2 P naught V naught. So total work done is 6 P naught into V naught. This should be our answer. Clear? Similarly, let us calculate what is the work done from the process A to C. Clear? So again I can write delta Q is equals to delta U plus delta W. Okay. So delta Q is equals to delta U. Always it is equals to 4 P naught V naught because change in internal energy is a point function. It is not a path function. Clear? Now what is the work done in traveling from A to C? So in traveling from A to C, just area under this graph, area under this AC graph, that should give the work done. So here, what is the shape of this figure? This is in the form of a trapezium whose area can be written as half base into H1 plus H2. So therefore I can write half into, what is the base of this diagram? Base is 2 V naught minus V naught is V naught and H1 plus H2. So first height I can take it as 2 P naught, second height is P naught. So 2 P naught plus P naught. So therefore, what is the total work done? Total heat energy supplied is 4 P naught V naught plus. So this is 3 by 2. So 1.5 P naught into V naught. So total it is 5.5 P naught into V naught. So this is the work done in traveling from A to C. Total heat energy supplied in the process A to C. Clear? Similarly, I am supposed to find out heat energy supplied from ADC. So ADC. So we are traveling from A to D and D to C. Clear? So again I can write delta Q is equals to delta U plus delta W. So delta Q is equal to delta U is always 4 P naught V naught, and what is the work done from traveling from A to D and D to C. So again I can say that in traveling from A to D, so here volume is not changing, so definitely work is not done. So work is done only when traveling from D to C. So area under DC graph already we have calculated, which is equals to P naught into V naught. So therefore plus P naught into V naught. So delta Q is equals to 5 P naught into V naught. So these are our answers. So I hope you have understood how we have calculated the work done by using first law of thermodynamics, and I hope you have understood that delta U, change in internal energy, is a point function, whereas heat supplied or work done, they depends on path taken, so we can call them as path functions.